Okay, so for this first question, we just want to know what x and y are after this code executes. And so we're given two variables. We have q initialized to 50.0, which is of type double, and then r, which is initialized to 2 and of type int. And so for x, we want to first divide q by r, and then cast that value to an int. And so what that should look like is this. And since we're dividing a double by an int, the value is of type double. But we notice that we are going to cast that to an int. And so we truncate that value, but then we notice that x will be of type double, and so we can do implicit casting here since we're going from an int to a double by adding a 0.0 at the end. And so from that, we can cross off C and D, since the string that we'll print out will have x printed out first before y. And then for y, it's just dividing q by r, which is what we already did for x in the first step there. So y is 7.5, and so the answer should be B. So this next question uses the random method from the math class, and we want to know what might be printed as a result of executing these two lines and then having x and y being printed at the end. And so knowing how the random method works, it returns a number from 0 up to 1 exclusive. So from 0 up to 0.99999 and so on, right? And then say for x, this line that initializes x, we multiply this by 10. So then we get 0 times 10 is 0. And then this will turn out to be 0.9 or 9.999 and so on. And then notice that we also cast it to an int. So then this will turn out to be 0 up to 9. And then we add 5 to that. And so the range of values that x can take on are 5 up to 14. So that's for x. For y, it's a similar process. After up to here, I want to say, let's just write this out. Y, and then what is this going to turn out to be? 5. I want to say it should pronounce something like 4 point, I don't know. I'm just going to say 999 because ultimately this is going to get cast to an int. And then adding 10 to that, the range of values y can take on are 10 up to 14. And so knowing this, we can just compare the answers, see if it fits into both ranges. We have 8 and 15. 15 is outside of y's range. 9 and 12, looks like this is the answer. Let's just check the other two just in case. 10 and 7, 7 is out of range for y. 15 is out of range for x. So B is your answer. So for this question, we just want to make sure that we're using a class's constructor correctly. And so we're given this date class, and its constructor has two parameters, the first being a string and the second being an int. And so we look at these choices, and for this last one, choice D, that is an automatic no because we're apparently initializing private instance variables in a public setting. We should be doing this in the constructor instead. So D is gone. Now for the rest of these choices, let's just go through these one by one. And so the first parameter is a string, that's fine. But the second parameter here is a string as well, even though it should be an int. So that's gone. For B, We have a string as the first parameter, int as the second parameter, so this looks good to me. I'm going to choose B as my answer, but let's just go over C just in case. And so we're only given one string, or one parameter, which is a string, and no second parameter whatsoever. So that's gone as well. So the answer is B. So for this next question, we are given the string, which is initialized to element OP. I've included the index values for reference here. And then we want to know what string 2 will be after executing these last two lines. And we can see that we're using the substring method. And so string 2 is first initialized to the substring of string 1 at index 3 up until the end of that string. So string 2 is, for now, initialized to OP. And so given that, and also looking at the next line here, where we're appending to the end of what is string 2 right now, we can cross out C and D. And then for this last line, we are going to append the substring of string 1 at index 2. And that's it, since we are taking the substring at this first index, up to the second index minus 1. So essentially, this is just one letter in the substring, which is N. And so string 2 is now OPN, which means the answer should be A. For this question, we are going to deal with if-else statements. And so the description reads, we want to use a method and want to return Renaissance for years 1400 to 1600. So let's just write that down. So Renaissance is going to be 1400. I'm just going to use X as a random variable, 1600. That is all inclusive. So we're going to use the less than equal to as the range. And then medieval for 400 to 1399 inclusive as well. And then other for any other year. So I'm going to say if X is less than 400 and X is greater than 1600 for other. And so we have this method definition with year as a parameter, and we want to replace missing code with one of these answer choices such that it matches this description. And so let's just go through this one by one, starting with choice A. And so we start off with an if year is greater than 1600 or year is less than 400. Category should be set to other, which matches what we wrote down here. And so that checks out. Then we do an else if. So if year is not greater than 1600 and year is not less than 400, then we go to this block of code here. And this checks if year is greater than or equal to 1400, category is equal to Renaissance. And to me, that checks out because we're using an else if for the second block, and we've already checked if year is greater than 1600 or not. And so if that's not the case, then this condition here with the else if essentially just checks if year is within 1400 to 1600, which matches what we wrote down here. And then for this last else if, we're going to check year is greater than or equal to 400. And that checks out as well because we've already checked if year was greater than or equal to 1400 at this point. And so this block of code checks if year is between 400 and 1400, which matches this line here. So based on that, I'm going to say the answer is A, but of course, let's just check these other answer choices just in case. So we have the same exact line or same exact if statement, initial if statement from answer A, but this time these next two if statements only utilize an if statement and not an else if. And so that means if, say, year is set to 1800, then of course this will run, category is set to other. But now since we don't have an else if for the second block, 1800 is also greater than or equal to 1400. And so this block of code will run and category will be set to Renaissance, which is not what we want. And then if we run this next block, this will return true as well, since 1800 is greater than or equal to 400. And so category will be ultimately set to medieval, which is not what we want. So that is crossed out. Let's go to choice C. We have if year is greater than or equal to 1400, category is equal to Renaissance. And so for that doesn't work out if year is ultimately set to a year greater than 1600, right? So if year is set to say 2000 for example, category will then be set to Renaissance, which is not what we want. We want that year 2000 to actually be set to other, right, based off the description. So right off the bat, we can cross that off as well. And the last one, we have the same if statement from choice C, and I've already explained why that will not work. So we don't have to look at the other if blocks. So that is gone as well. So the final answer will be A. So for this question, we have an exclusive De Morgan's Laws question where we're asked which one of these choices is equal to this expression right here. And one way to approach this is to just write a truth table that outlines all the possible choices of true-false values for x, y, and z, which are the variables in the expression, and then also outline which true-false value it evaluates to depending on what expression is given. So I evaluated all of that for A, B, C, and D, as well as the original expression here, which I denoted as V. And if you think that this is a little tedious, it's a little too much, believe me, it is. I think this took me around 5 minutes or so to get every one of these true-false values in here, which say you're given this problem in the exam, you're in a time constraint, right? You want to try to solve as many problems as you can, hopefully all of them within the time limit for multiple choice questions. And so I would advise for you to know De Morgan's laws like in and out. And it's really not that hard. If you can just pretend like this is just a math problem where the not operator is a negative sign, and then say the and operator is a plus sign, the or operator is a minus sign. So if I'm going to take A, for example. All right, what is going on? So let's take A, for example. If we just say negative x plus y plus z, right? So I just replace negative or the not operator for negative sign and with the plus sign. And if you recall from, I guess, basic algebra, hopefully you know that the negative sign distributes to both x and y. So this plus sign gets turned into a minus sign, and the plus c isn't affected at all, right? So hopefully you know that from algebra. And so that's essentially what De Morgan's laws is. And so if we apply that to all of the answer choices. It's gonna give me a second. So this was A, right? Let me just write that down. For B, this is going to turn out to be that. And hopefully you can track, if you can just do it, I guess, on your own. Just substitute the not operator for negative and then an with plus sign. This will get turned into this, and as you can see, this matches the original expression here. So I'm going to highlight that as my answer. But I'm just going to go over the rest of these real quick to show you that the rest of these are not going to match the expression given. And then if I just switch up A to B logical operators instead, so as you can see, if we use De Morgan's laws appropriately, we're going to see the original expression has no AND operators. So if we did all of this, we would have crossed out A, we would have crossed out D, we would have crossed out C. So B is the only expression that simplifies to only OR operators. And then if we use the truth table method, I guess, all the values in V that we've calculated match all the values in B. And so that's how you know that we've generated an equivalent expression. So the answer is B. So for this question, we were using a double for loop, and we have the outer loop already declared as j equals 4 up to j greater than 0, decrementing by 1 each iteration. And we want to find out which answer choices would fit in as the inner loop header, as we're printing out the value of k each time. And we want to have the output look like this. And so I guess we're just going to have to go through this one by one. So at the first iteration, j is 4. And if we choose answer A, k equal to 0, k is less than 4. And we're incrementing by 1 each iteration. And knowing that we print out k for each iteration of the inner loop, which is going to be this answer choice, this is going to print out k is 0, and then k equals to 1, and then k equals to 2, and then k equals to 3, and then it stops at k equals 4 because 4 is not less than 4. And so that will be when j equals 4. That will be what k will be, and ultimately what the output will show. Say for j equals to 3, this will be k equals 0, k is less than 3. So that'll be 0, 1, 2, and then it stops at 3 because 3 is not less than 3. And so hopefully you can see the pattern. When j equals 2, k is going to be less than 2 set here. So k will then be 0 and 1, and then it stops at 2 because 2 is not less than 2. And then for j equals 1, we're just going to have 0 because 1 is not going to be less than 1. And so this matches the code segment here as the output. So we can say that the answer is going to be A. But say if we chose B, we can see the difference between this and A is that we just have a less than and equal to, or equal to sign instead. And so if that was the case, J would go, or the inner loop would have an extra iteration, like so. And so this would be the answer, or this would be the output if we chose answer B, which is not what we want. So we can say B is gone. And for C and D, we set K equal to what J is at the start of the iteration. And if that was the case, K would be then set to 4 if we started the loop from the start. And so this would just look like something like 4, 3, 2, 1. It'll just go, it'll decrease its value for each line, which is not what we want, right? And so we can say that the answer will be A. Okay, so for this problem, we just want to analyze how many times hello will be printed out based off of this code segment. And so here we have a double loop. J is initialized to 1, which is going to be used as part of the outer while loop. And then once we enter that loop, we have a for loop that utilizes the K loop variable, which will then determine how many times hello will be printed out every J iteration. And so if we just track how many times K will be, I guess, after every J iteration. So when J equals 1, this is the initial value that J takes on. K will then be 0, 1, 2, 3, 4. And so hello is printed out 5 times at this point. And then it stops since 5 is not less than or equal to 4. And then J will be incremented by 1. And so for J equals 2, the same thing happens with K, 0, 1, 2, 3, 4, stops at 5, hops over to J equals 3 after it's incremented, and 3 is still less than 4, so we go K 0, 1, 2, 3, 4, and then it stops there. Now, when J is 4, it does not enter the loop since 4 is not less than 4. And so ultimately, this code will run 15 times. So there's your answer. For this question, we are going to develop sort of a blueprint for designing a class. And so we're going to try to create a movie class that will contain attributes for a movie's title and its average user rating from 0.0 to 5.0. Hopefully you can tell that this is of type double, which may be useful. The class must also contain methods to allow the attributes to be accessed outside the class, which just tells me that these methods should have the public keyword associated with them, since they need to be accessed outside the class. And so a class design diagram for the movie class will contain 3 sections. The first contains a class name. And so as you can see, all these choices have movie as a class name, which is good. The second section contains 2 instance variables and your data types. So that will be this box here, or this row, with title and rating. And then the third section contains 2 methods and their return types, which will be the get title and get rating. The plus sign indicates a public designation, and the minus sign indicates a private designation. So which of these diagrams matches the most based off of this description? And so we can see for A and B, these have public instance variables, whereas C and D have private instance variables. And I hope that you know and you've seen for each class, they should only have private instance variables associated with them, so that an object, once it instantiates a movie object, then that object has the title and rating instance variables only associated with that object. So that would mean that we would only need private instance variables. And so A and B are for sure not the correct answers. Now, it seems to me that the difference between C and D is that rating is of type double for C and rating is of type int for D. And as we can see from the description they gave us, we have a scale from 0.0 to 5.0. And so this is a type double for rating. And so the answer will be C. So for this question, we have two class declarations that we need to take into consideration. We have the apartment class and the duplex class. And so we want to replace this missing code here as part of the print info method, which is a void method, as part of the duplex class. Which one of these choices will replace that code and compile without error? So as you can see, for the duplex class, we have two instance variables of type apartment, which is a separate class declaration. And if you notice in the apartment class, we have one public method and one private method. And this private method I'm going to underline here because this is important. We can't use dot operators or really call it outside of the apartment class in general, since this is a private method. We can only call and use this method within the apartment class only. So anything that involves a dot operator and then the get tenant method is going to be an automatic no as an answer. So B and D are not going to be the correct answers here. So now we're left with apartment.calculateRent or unit1.calculateRent. And unit1 is declared as an instance variable of type apartment in the duplex class. And so which one of these makes more sense? Well, I am going to lean towards C here because unit1 is again declared as an instance variable of the duplex class and it's of type apartment. And so it makes sense to use the calculate rent method since it's a part of the apartment class, right? And compared to apartment.calculateRent, well, apartment, we're not calling anything, there's nothing declared as static, so we don't need to use really a class name in general. And unit one makes more sense since it's already declared as an apartment type. So C makes the most sense here as the answer. So for this question, we have this point class declaration where we have two instance variables, its constructor, two getters for the two instance variables, and then this method is equiv, which returns a Boolean and takes in a point object as its parameter. And we want to know, or we want to figure out which one of these choices will replace this such that it returns true if this point object, which is the current object that is being referenced at this moment, is equal or equivalent to the point object parameter and return false otherwise. So let's just go through this one by one. So for first choice, we have get x core equals to x core and get y core is equal to y core. Well, this x core and the y core by itself is a red flag because we can't necessarily reference these instance variables by itself like this. We'd most likely use the dot operator. So an object name and then a dot operator and then the instance variable, or better yet, using a getter so that the getter, like get x core and get y core, uses or returns the instance variable, which is actually applied here. So since that's the case, I'm going to say get x core and get y core is one object, but x core and y core by itself is not being referenced by another object. So the object name dot the dot operator and then x core, y core, you can't necessarily do that by itself like that. So I'm going to say A is gone. Other p dot x core equals to x and other p dot y core is equal to y. Well, x and y is going to be a red flag for me here because x and y aren't really defined as variables. It's only used as placeholders for the parameters in the constructor. So that is a no-no. So that is gone. Other p dot get x core, that looks good, equals to get x core. So And then, of course, it's reciprocal, other p that get y core equal to get y core. This looks good to me because we are accessing the x coordinate instance variable to the other p point object, similarly with the y core. And then on the other side, we have get x core and get y core, which is going to reference this point object. So remember that this keyword. So that accesses this point object's x coordinate and y coordinate, and it checks that with the other p's x coordinate and y coordinate respectively. So I want to say it's C because this looks good. Let's just check D just in case. We have other p equals to this. For this one, this equals operator checks the actual memory addresses. If the other p memory address as well as this memory address have the same exact number, or I guess memory addresses in hexadecimal or whatever, which is most likely not going to happen because this and other p should have been instantiated separately, which means they take on a separate memory address. So these memory addresses are probably not going to be the same, most likely. So I'm going to stick with C as the answer. Okay, so it's looking like this problem is an array question. Since we're given this method, it's intended to return the max integer value contained in the array ranges. And we're also given this precondition where this array is going to contain at least one element, so we don't have to worry about an empty array. But it seems like this method doesn't always work, and we want to make a change to a line so that this code will work as intended. So it seems like we're going to have to go through this one by one. First option is to change line 4 to set max equal to the first element in the array given. That is an intriguing option because we are trying to figure out what is the maximum integer value contained in the array. And so setting the max equal to the first element in the array, since we're traversing through the array using this enhanced for loop from start to finish, and then for each element in the array, we're comparing that value if that value is greater than the current maximum so far that we've traversed through the array at that point in time. And if that's the case, then we're going to set the max equal to that value. So line 7 and line 9, I don't think there's any problem with those lines. So for C and D, we can cancel them out. So we're going to change line 4. It's just a matter of what is the reason why we're changing line 4. And I feel like choice A is going to be our answer here because it makes sense to set the max equal to the first element that we see in the array. And then as we're traversing, if we see an element in that array that is greater than the current maximum, then we're going to set that maximum equals to that value. So I'm going to say A is the answer. Let's see, for B, we are setting the max equal to the maximum value that can be represented by an integer, which I don't think makes sense because at that point, the max won't change at all since there's going to be no value that's greater than the maximum value that an integer can take, right? So I'm going to say the answer is A. So for this question, we are dealing with a text file, and we've already initialized a file and scanner object, as well as a username's array list of type string, and we want to assign this array to the array list usernames. And so we want to figure out which one of these choices will do that for us. And so let's just go through this one by one. Seems like all of these have the hasNext method as the condition of a while loop. So that's good. So that just means we're traversing through each line, the array or the text file until there's nothing left. And so for A, we are assigning temp to be the next line's first letter using the substring method. And so, for example, for A, let's just write this down. For A and say the first line, Cohen Isabel, temp will be C, and then usernames that we're adding or we're appending the next line after that, which is Lee Cindy, to the first letter of the previous line. So this will just be something like this. And that applies to the rest of the lines of the file. And so, of course, this is not equal to I Cohen, which is what we want to have in the array. So A is gone. For B, we are assigning the first string to be Cohen Isabel and the second string to be Lee Cindy. And then we want to add the second string's first letter, which is going to be L, to the first string. That we've already initialized. And so, of course, this is not matching I Cohen in the array, so that's gone, and of course that applies to each of the lines. And so that just means that's not a good answer. For C and D, we use the split method, splitting across the dash. And so say, let's take Cohen Isabel, for example, again. Temp will now be something like Cohen and then Isabel as separate elements in the array temp. And that goes for D as well. Now, for C, we are adding the second element in that array, second element's first letter, and then adding that on to the first element in the array. So for C, this will look like this. We have I Cohen, which, as you can see, is what we have for the intended answer. For D, we are going to add the first element in the array, the first element's first letter, and then adding that on to the second element. So that'll be something like this, which is not what we want. We want I Cohen instead, and I can assure you that this applies to each of the rest of the lines as well. So the answer is C. So we have an array list problem here. We want to figure out what this array list will be at the end after running this as part of this method. And so let's just go over what this method is doing. And so we have this for loop. It seems like we are iterating through the elements in the array list from 0 or index 0 up to the size of the array list. And then for each element in that array list, we are retrieving its value. And then we are checking that value if it's an odd number. So modulo 2 equals 1 is checking if the value is an odd number. So for example, if say we are dividing 7 by 2, 7 is an odd number, by the way, we have 3 with a remainder of 1. So modulo takes the 1 since it cares about that. And so this applies to all odd numbers. Say for an even number like 4, it'll divide evenly, meaning there's no remainder. And so this will apply to all even numbers. And so this is checking if the value is an odd number. And if that's so, we want to set that value to be incremented by 1. All right, so seems simple enough. So for every odd number in this array list, we want to increment that element's value by 1. So Going from start to finish, we have 1, which is an even or an odd number, which then turns into 2. 2 is an even number, so that doesn't change. 3 is an odd number. Increment that by 1. 2 is an even number, and then 1, we are incrementing that by 1 since it's an odd number. So this will be our array at the end, which should be C. Here's a 2D array question. So what we want to do is find out which one of these choices is the correct initialization for this 2D array, such that sum is equal to 3, essentially. So we want to investigate what this for loop is doing, because sum is involved in this for loop in some way. And so essentially what this is doing is we're going through each row of the 2D array, because we're going from 0 up to the 2D array's length attribute, which is essentially its number of rows. And so using that loop variable j, we are going to access each row, right? Because when we're accessing 2D arrays, remember how the first number indicates the row index and then the second number indicates the column index. So if we're going from 0 up to the number of rows in the 2D array, right, we're going here, here, and here. And for each row, we want to access the row's second index. So let's say we start at row 0. Its second index will be this number here. Let me just circle it. And then the second row is going to be this number, and then the next corresponding row is going to be this, and then so on if there were more rows. So essentially, we're going to go down this column here and add up all the numbers. And so if you haven't noticed already, this is answer or choice A. And so if we add the numbers straight down this column here, we get a sum of 4, which is obviously not equal to 3. Go down this column for choice B. Sum is 2. That's wrong. Go down this column for answer choice 3. That is not equal to 3. And then we go down this column here, right? Because this is the second index of each row. And then you can see that the sum is 3, so the answer is D. Here's another 2D array question. This time we have our 2D array already initialized for us. And so what we want to do with this whole code segment is to figure out what best describes this code segment. And so again, our 2D array is initialized for us. We're initializing this variable called and equal to 1. And then we notice we have this double for loop. The outer loop uses an enhanced for loop that accesses each row of the 2D array, which is essentially, again, a 1D array, which is denoted by this. And I can just highlight this as well, I guess, that each row of this 2D array is essentially a 1D array, right? And the same for this row, the same for this row. And then this inner loop, once we access each row of the 2D array, we're going to access each element in the array that we're looking at that moment. And then we check for each value if that value is greater than 0, otherwise known as a positive number. We're going to multiply that value with whatever is stored in ANDs, right? And so it asks us what best describes the behavior. It prints the product of all the elements. Well, this if statement checks if we want to multiply each positive number in R in the 2D array, right? And so that is not true. Prints the product of all the negative elements. Well, values greater than 0 is checking for positive numbers only. So that's gone. All the positive elements. Said that already. And so that's looking like the answer. Let's just check this just in case. Prints nothing because of runtime error. Well, it doesn't seem like to me that we're doing anything like dividing by 0. We're not accessing each element manually, as in we're not checking, say, we're not doing anything like our, I don't know, what is it, 3, 0. We're not doing anything like this. Otherwise, of course, this would give us an exception, an out of bounds exception, but we're using enhanced for loops instead. So this does all the work for us, essentially, because it takes it takes a copy of each element and gives it to us for us to use. So it's not looking like that is the answer. So we are going to deduce that the answer is C. So for this question, we're dealing with the selection sort algorithm given to us as a method here. And we want to use this on this array that has been initialized for us. And we want to know what this array will look like after 3 iterations of the selection sort algorithm. And so obviously, if you don't know what the selection sort algorithm is compared to, say, the insertion sort come the exam, obviously you can just go through this algorithm and trace it step by step. But if you know what selection sort is intuitively, this is a walk in the park. Essentially, so for the first iteration, we're going to start at the first element here. We're going to mark it as the minimum. And then we're going to go through each element in this array and figure out which element is the minimum out of the whole array that's been unsorted still. So for example, we start at 40 here for the first iteration. We go to the next element, which is 30. 30 is less than 40, which means that 30 is now marked as the new minimum. Or I should probably mark this still, since we're going to swap something with that at the end. Now we go on to the next element, 50. 50 is greater than 30, so that doesn't get marked as the minimum. 60 is still greater than 30, but 10 is less than 30, so we're going to mark that as a new minimum. And 20 is not less than 10. And so 10 is going to be our minimum, and so after we traverse through the unsorted portion of the array, we're going to swap the first element with 10 here. So this array will now look like this. So that's the first iteration. And then 10 is now sorted. So now we move on to 30. 30 we're going to declare as our minimum. 50 and 60 are greater than 30, so is 40, but 20 is less than 30, so we're going to mark this as the minimum, and then swap it with the second element in the array in the second iteration. So now the array will look like this. So 10 and 20 are now sorted. Now we move on to 50. 60 is greater than 50, so we're not going to mark that as a minimum, but 40 is, so at that point we're going to mark it as a minimum, but then we go on to 30, which is less than 40, so that's going to be our new minimum. And since we traverse all the elements that are unsorted at this time, we're going to swap 30 with 50, which is the third element in the array. And then after the third iteration, we're going to have an array that looks like this. And so this is after the third iteration. So The answer is going to be B. So the last question of this video is going to involve recursion. Since we have this function that has a recursive call, since it calls itself, and we want to know what's going to be printed when we call mystery with j equals 10 and k equals 0. And so let's just keep track of each recursive call and what values they take in. So with this first recursive call, this initial call when j equals 10, k equals 0, 10 is obviously greater than 0, so we're going to enter this if statement here. And this statement is going to call mystery with j minus 2, which is now 8, and k plus 2, which is going to be 2. And so let's just write this down to keep track. And let's just draw this little arrow to signify that we went from this call over to this call. And so with this mystery call, 8 is greater than 2. And so we're going to call mystery j minus 2, which is 6, and then k plus 2, which is 4. And so with this call, 6 is greater than 4. And so we're going to call mystery yet again j minus 2, which is 4, k plus 2 is 6. Now for this call, 4 is not greater than 6, and so we're going to skip this recursive call and go into the print statement, which is going to just print out j and then a space just for printing purposes, but we're more interested in j. And so for this call, j is 4, and so we're going to print that out. Or we don't need a comma, since we're just going to use a space to print. And so this recursive call is done. And so we're going to trace back and look at this recursive call. And this recursive call has a value, has a j value of 6. And so we're going to print that out. This call is done. We go back to its previous call of mystery j equals 10, k equals 2. J is 8 in this case. And so this call is done, and then we go to our initial call that we had when j equals to 10. And so our recursive calls are now complete. And this is going to be our answer, which is D.